Hello everyone. Welcome back to Daily LeetCode channel. Today's LeetCode problem is 1292, maximum side length of a square with sum less than or equal to threshold. Let's understand the problem statement. You are given an m by n matrix called mat, and an integer value called threshold. Your task is to find the largest possible square submatrix such that the square has equal height and width, and the sum of all elements inside that square is less than or equal to the threshold. If no such square exists, you should return 0. In simple words, you need to look inside the matrix and find the biggest square you can form, where the total sum of its elements does not exceed the given threshold. The output should be the side length of that square, not the area. That's the problem statement for LeetCode 1292. Now let's move on to the examples and solution approach. Now let's understand the problem better with examples. Example 1. We are given the matrix as a *** 2D array of elements 3 rows and 7 columns ***, and the threshold value is 4. The output for this example is 2. This means the maximum side length of a square we can form, such that the sum of all its elements is less than or equal to 4, is 2. If we look closely, a 2 by 2 square made of ones has a total sum of 4, which satisfies the threshold condition. But any larger square, like 3 by 3, will have a sum greater than 4, so it is not allowed. That's why the answer for example 1 is 2. Example 2. Now let's look at example 2. We are given the matrix as a *** 2D array of elements with 5 rows and 5 columns with all elements are 2, and the threshold value is 1. The output here is 0. This means we cannot form any square, not even a 1 by 1 square, because every element in the matrix is 2, which is already greater than the threshold. So, no valid square exists, and the answer is 0. These examples clearly show how the threshold condition limits the size of the square. Now let's move on to the solution approach. Intuition. The core idea of this problem is to find the largest possible square submatrix, whose total sum does not exceed the given threshold. A brute force approach would be, try every possible square, calculate its sum every time, but recalculating sums again and again would be too slow. So instead, we use a 2D prefix sum technique, which allows us to calculate the sum of any square in constant time. Also, since the problem asks for the maximum side length, we start checking from the largest possible square and move downward. Approach. Build a prefix sum matrix. Create a 2D prefix sum array where prefix underscore sum, I, j, stores the sum of elements from 0, 0 to I1, j1. This helps us compute the sum of any square in O, 1, time. Start from the largest possible square. The maximum side length possible is minute, number of rows, number of columns. We try square sizes from this value down to 1. Check all squares of current size. For each possible starting position, use the prefix sum formula to compute the square's total sum. If the sum is less than or equal to the threshold, we immediately return the current side length. If no square is valid, if we reach size 0, return 0. Prefix sum formula used to calculate the sum of a square starting at row, col, with side length k. Sum equals prefix underscore sum, row plus k, col plus k. Prefix underscore sum, row, col plus k. Prefix underscore sum, row plus k, col, plus prefix underscore sum, row, col. This gives the square sum in constant time. Now let's run the code with the given examples. As you can see, the output matches the expected results. Everything looks good, so let's go ahead and submit the solution. And great! The solution is accepted successfully. This confirms that our prefix sum approach works correctly for all test cases. That's it for today's problem. In this video, we solved LeetCode 1292. Maximum side length of a square with sum less than or equal to threshold, using an efficient 2D prefix sum technique. If you found this explanation helpful, please like the video, share it with your friends, and subscribe to the channel for more daily LeetCode solutions. The problem link and full solution code are available in the description below. Thanks for watching, and I'll see you in the next video. Happy coding!